Hey guys, what's going on? Today I'm continuing with the RB30 build slash teardown. I've got Aaron with me who works at a machine shop, and he's hopefully, after taking some measurements, going to give me the good news that I can reuse all the bits and pieces that I've pulled out of the RB30 so far. If he gives me bad news, then we're going to start discussing other options that probably involve going forged if I'm allowed to. So let's dive right in and we'll get Aaron to explain what he's doing as he's measuring things up. Alright, so what do you got there?
I've got a micrometer. This one is a 3 to 4 inch micrometer. We measure everything in imperial in our workshop just because the numbers are smaller. It's just as accurate, but it's easier to remember 3 point something inches instead of 86 point so on and so forth.
That doesn't work with my head though. I like millimeters. I don't know why.
When you've been in the trade for nearly 10 years and you've been using imperial measurements the whole time, it makes more sense than metric.
Yeah, fair enough.
But yeah, so we're going to measure all the pistons, make sure none of them are collapsed or out of round in the wrong direction, and then we're going to check the cylinders and see how much clearance they've got. We'll start with the dirty piston. It's seen a bit of water and a bit of dirt. So when it comes to measuring a piston, you want to measure it on the major axis, right in the middle of the skirt, 90 degrees from the pin. It's always the widest point. Pistons aren't actually round, they're oval shaped. General rule of thumb, the measuring point is in line with the main rib on the underside of the pin bore there. So our standard point will obviously be right here.
I can see you kind of wiggling it backwards and forwards. What's that about?
Make sure I get the right pressure on the measuring equipment so that I've got an accurate measurement. So we've got 3.385 and about 3 10,000ths.
So I should be writing these down, right?
Not necessarily. I've got a hunch that they're all going to be within a couple 10,000ths of each other. It's usually the case on these RBs, unless one is severely damaged, which doesn't look to be the case. So we'll put this one back and go to the next one after I wipe all the the mud off my fingers.
That could add a couple of thousandths.
Yeah. Yeah, it would have just got crap in it while it was stored.
Yeah.
Not uncommon. So this one's about 4 10,000ths smaller.
Is that a lot?
On a standard cast piston, yes. The standard piston of ball clearance is 7/10 to 1,000th of an inch, so...
I can't even picture the numbers that you're saying. I don't understand the imperial... Like, I understand it, but my brain just can't figure it out.
40,000ths of an inch is 1 millimeter.
40,000.
So yeah, that's not a very large amount, but when you're going for precise things like cylinder ball clearance, it can make a big difference.
Right.
It's like if they were new pistons, we'd hone those cylinders to 2 different sizes. So number 4, same as number 5. So we've got 3.3, 84 and 9/10. They're getting progressively cleaner as we get to the front.
Yeah, yeah.
This one, on top of the piston here, looks like it had a bit of blow by past the rings.
Right.
See how it's all clean there?
Clean.
Oil would have been getting up past that and causing it to clean the carbon off the piston. Yeah, you can see that the ring's nearly worn the whole way across on the second oil control ring.
Yeah, right, okay.
3.385 on the dot.
Off the top of your head, do you know what they're meant to be?
Round about that, so 86 millimeters is nominal bore size.
Yeah.
Your piston will be just under that.
Yeah, right.
But manufacturers will have different grade pistons, they call them.
Yeah.
So there'll be a few 10,000ths of an inch difference in size. So
right.
When they finish all the cylinders, they remeasure them and put the correct grade pistons into the cylinder.
Oh, because of differences in cylinders when they make them.
And difference in size when they make the pistons.
So they just have like big batches that are all the same size, basically, that way.
And then, yeah, they'll just adjust the clearance by a few tenths by putting different pistons in, depending on where the cylinder honed to.
Yeah, right. That's actually really smart.
Yeah, well, when you're making thousands upon thousands of everything, it's a pretty easy thing to do. So down to number 2, it's 3.3, 84 and 9/10 as well. I've got a feeling number 1's going to be the same. Oh no, I'm wrong. 3.3, 84 and 5/10.
That's bigger.
Smaller.
3.3845. Oh wow.
Yeah.
Okay. Yeah, right.
That's another 4 10,000ths smaller. So
that's the smallest one.
Yeah, and nearly a whole 1,000th of an inch difference between number 1 to number 6.
And then all the middle ones are basically the same.
Yeah. Could be wear on the piston skirt Could be difference in bore size from the manufacturer.
Oh yeah, and they just put the corresponding piston in that cylinder.
Yeah.
Right.
So we'll measure all the cylinder bores in the block and see how much clearance they've got.
Cool.
So I got a feeling by the look of everything, it's done a lot of K, so it might be a little bit wide.
Yeah, right. We don't like that.
No. Wide means piston slap, and piston slap means collapsing pistons, and that can lead to catastrophic failure.
I was just going to say we don't like wide holes, but you know, also that.
So I just noticed while we were measuring the pistons that the number one bearing here is through to copper, and it's got quite a few streaks in it, but it hasn't deformed the bearing shell itself yet. And the crankshaft doesn't look too bad. Doesn't have any big gouges in it. So it might have just been saved from doing a major bearing spin on number one there.
All right, so now that Aaron's measured the piston skirts, that's right, isn't it? Because that's the most accurate.
It's the widest point of the piston. It's where you measure your clearance from.
Right, okay. So because he's measured that, now we're going to measure the bores in the block to see how much wear the block has by checking the piston to bore clearance. Cool.
So we pretty well just need to measure the top of the cylinder across the major and minor axis of the cylinder, which is driver's side to passenger side.
Right.
Because that's obviously where all the forces of the engine get pushed into.
Oh, because the pistons go right, because the way they move the
Yes.
crank. Yeah, okay.
Yes, so your major thrust side is the driver's side in Australia. Obviously it's backwards in America because, you know, they're on the wrong side of the car. So yeah, the right hand side of the block will be your major thrust side, and the left hand side will be your minor thrust side. When you've got a motor that's older like this, you get a bit of ring wear. So you can see in the top of the cylinder here, that line where the top ring comes up to.
Yep.
Fortunately, it doesn't feel like a super big lip, but there is a lip there, so it's got a bit of wear. But yes, we use an inside micrometer to measure the inside of the bore there. We just wind it out, get the feel right, and then we check that size with the full size micrometer, just because the gauge on this is not real accurate, because these wear really badly. So pretty well the same as measuring the piston. You want to just get the feeling right in the bore, and then you transfer that same feeling to the micrometer.
Okay.
So we've got 87 and 6 or 7 tenths. So 3.3, 87 and 7. So that's...
My brain can't deal with these numbers.
It'd be worse if it was
At
metric.
all.
There'd be a lot more of them.
So is that good or bad?
That's not what we really wanted to see if you were to want to reuse those pistons. It's more than twice the factory piston to bore clearance. It's quite up there.
Right, okay.
It's definitely fine to go to the next oversize, but it's not what you want to see for reusing a piston. This seems to have quite a bit of ring wear in this one, which definitely would explain why it looked like it had a bit of oil blow by the rings. Very, very wide piston to bore clearance on this one. 3.390. That's quite a bit. It's like over 5 thousandths of piston to bore.
Yeah.
We'll keep going and see how bad the rest of them are. 3.389 on the next one, so it's a little better, but not good. We'll keep going.
Sorry, what was number 5? 3.390?
Yep.
Okay. So do you think that would have been enough where to have any noise or anything like, would there have been any sign of that happening?
You definitely would have heard it. It would have sounded a little bit like a lifter tick, but it's it's what you would call piston slap.
Yep.
It'll be particularly noisy on cold start, like with a forged bottom end build.
Yeah, okay.
You'll hear that piston slapping away until it gets a bit hotter, and then the noise might go away a little bit. It's not feeling any better than the others. Yep, 3.390 in number 3. At least it's kind of consistent.
Consistently bad.
But it's not consistently broken, which is the main thing.
Yeah, true.
But being an RB30, it probably did receive a lot of abuse. We all know what people love to do with a 30. So we've got 3.390 on number 2 as well. Number 1 feels alright.
That's good, we got one cylinder.
Get the crank in my hand.
That's what she said.
So we're 2 thousandths better on number 1 with 3.388.
The second worst cylinder.
Yeah.
Cool.
Because all the middle ones are equally bad to each other.
Yeah, right.
It's not the worst RB30 I've seen. It's not amazing either. But
so realistically though, with a bore and some bigger pistons.
Yeah, and you want to clean it up anyway. Get rid of the marks and stuff, and put a correct finish in the cylinder, so you've got a nice crosshatch for oil retention to lubricate the skirt and to get good seal on your rings.
I've always wondered about that, because in my mind I'm like, okay, you want this, like a nice smooth internal surface on the cylinder.
Yeah, it's actually complete opposite. You want the correct roughness so that you get good seal on your rings, the right amount of oil getting past and all the excess being scraped back down, and so it lasts better and seals better.
Yeah, okay.
But yeah, so you can see further down the bore, there's some staining from water where the motor's been sitting and it's got moisture in it.
Yeah.
Just down here.
Yeah.
There's a little bit of a patch on there where the skirt's rubbed on the cylinder wall. And we've got rust in cylinder 6.
Yeah, yeah.
And we've got some bad staining in 5. So it's obviously sat with water in it. To check on RBs is this little Welsh plug all the way in here. So some of the older RB30s, they tend to corrode out and then you don't get correct coolant flow. It can cause overheating issues because your coolant's not flowing the right direction.
Right, so you want that plug there, or you want to remove that plug?
You want that plug there because they corrode away and then water flows through it, and you don't get the correct coolant flow through your block and cylinder head. When we clean the blocks, we tend to take all of the Welsh plugs out and all the gallery plugs out, so when it gets chemical cleaned, it all gets flushed out correctly. We're going to measure up the crankshaft now. On first inspection, we can see that the main journals look really nice, but the big end journals have got some scoring across the underside. It's not bad enough to have spun bearings, certainly where it starts. You can see the big end bearings are all worn out. They're all through to the copper and some places nearly to the backing material. That does not mean the crankshaft is bad, because sometimes you can just get some light marks and it's still within spec and you can just polish it and go again. Or if it is a little bit too far out of spec or not round anymore, you can grind it to an undersized bearing. So you'd go 10,000ths of an inch, so 1/4 millimeter smaller.
On the crank?
Yes.
And then you go, what, a bigger bearing?
Yeah.
Okay.
So we're going to start with the big end journals. So I'll just check the zero on my micrometer and we'll start measuring. So we've got our specifications I got off the computer from work. So we've got 1.967 to 1.967.5 for the big ends. It's only 0.5 thousandths of an inch tolerance. So not a lot of room to play with. First, when we're measuring up journals, we want to check it for round and taper and hourglass or barrel. So if it's hourglass, obviously it's smaller in the middle of the journal than the outside edges. If it's barreled, it's smaller on the outside and wide in the middle. And obviously if it's out of round, that's an issue, because you'll have clearance that's one size this way and then a different size the other way at 90 degrees. But yeah, same as the other measuring with the mics, you've got to get the right feel and just see what it measures. If it's worn, it'll be smaller from the top to the bottom of the journal as opposed to the sides, because obviously that's where all the forces are going through it. So we've got 1.9, 67 and 7/10. It's actually over top size. So it's 2 10,000ths over top size. It's not uncommon for them to be on the upper end of this tolerance or over, which is good.
That's good, right?
Yes.
Yeah.
Because when you got,
that's what my brain
when
was
you
trying
got
to do.
small marks in it, you can polish them out. You will take material off, obviously.
Yep.
So
it's better to have more and then you can take it away.
yes.
Yeah.
Before we go on to the next one, I'm going to measure the opposite direction to see how round it is, and
Yep.
I'm going to measure side to side. So this one's exactly on top size at the sides. So we could be getting a wide measurement from a small lip on those marks. This one's 967.5, which is exactly top size. Yeah, so I'll just give it a little measure side to side, see if it's straight. Yep. Doesn't seem to have any hourglass or barrel in it. We'll go on to the rest of them. So we've got 1.967.5 on the number 2 journal.
That's the top?
Yep, good start as well. And 1.967.4 on the side.
Little small.
1 10,000ths. It's not much at all. We'll have a tolerance of 3 10,000ths for out of round or taper normally on each journal.
So what's more important, the top measurement or the side measurement? Like if the side is out, but the top's good.
They're both as important as each other.
Okay.
So you want them to be as close as possible. Because obviously the closer they are, the rounder the journal is.
Yeah, right. Okay.
So you get a nice consistent clearance as the engine's rotating. So number 3, 67 and 5. And same on the side. So that one's pretty well perfectly round. Same size yet again on number 4.
This is looking good.
Yes, despite the marks in the big end journals, they measure very good, which is usually what you want to see. So on the sides, we've got 67 and 3, so that's 2 10,000ths. So that's still within our tolerance. So that's within our 3,000ths tolerance for out of round wear, and it's on the top end of the spec for the journal size still as well. So
Yeah, cool.
67 and 5 again, and 67 and 4, and 6, 7, 4 for the side. You're gonna have a massive long list of measurements, and then you're gonna look at it and be like, I'm so confused, it's in imperial. 967 and 5 again, 67 and 2. So that one's on the limit for wear.
Okay, so that's good news, right? Everything's within spec, and the top and the side is within tolerance.
So all the big end journals are okay, despite the appearance of scoring from the bearing making contact. That's probably just due to the motor being old and quite a lot of Ks on it, evidently.
All right, but still, that's good news overall, right?
Yeah,
Nice.
there's no major marks other than the light scoring. You haven't hit any of the rod bolts on the journals when you've disassembled it. A common mistake a lot of people do when they're disassembling motors with a integral rod bolt like this, you try and take it out and you accidentally knock that thread into the journal and it causes a big mark. And yes, usually you have to grind the crankshaft to get that mark out.
Right, so we don't need to grind that at all.
No, we'll see how the main journals measure up.
What do you call these journals?
It's a big end journal.
Big end journal, main journal.
Yeah.
Okay, and then little end is obviously where the
Yeah, the small end of the rod.
Yeah.
Very, very simple terms.
Big, small.
Yes, we are cavemen. 0 on my mics, right, so we'll start measuring this. So our main journal tolerance, 2.163 and 4/10 to 2.164 and 4/10. So we've got 1,000ths.
So bright, I can't see anything. There we go.
We've got 1,000ths tolerance on the main journal, so twice as much for size tolerance.
Oh wow, okay, cool.
I say twice as much, it's still not much at all when you compare it to a normal measurement if you were to be building like a house or something.
Yeah, it's still like a fraction of a millimeter, right?
Yeah, it's not something you normally notice with the eye if you haven't been doing it for a very long time. Normally, you won't really start seeing it until it's like 5,000ths or more.
So what, 5,000th is what?
What do we got? 10,000ths is a quarter, so that'll be an eighth of a millimeter.
Jesus.
Yeah.
Okay.
Okay, so we've got the same thing again. We've got to check multiple directions and check for taper. So number 1 main journal across the top is 2.164. So right in the middle of our size tolerance range, which is a good place to be on one of these RBs. Gives us a bit of leeway when it comes to bearing clearance, and it's exactly round, which is a great thing to see.
Awesome.
So hopefully the other 5 journals are all exactly the same.
I don't think you need to measure them. I think we just take that as the rest of it is perfect, right? That's it. It's done.
Every time people assume that, they end up doing in main bearings or big end journals. Something you always have to do is measure everything.
Yeah.
It's like when we assemble, we check every single bearing clearance with a dial gauge and we record exactly what they are so we know what it was at. So we've got 63 and 8/10 on number 2, and it's round. 64 and 64. But yes, it's quite normal for it to have a few tenths size difference, and a lot of the time with older motors, particularly like American ones, they'll be a different size on the thrust. So that's one of the other things you need to check. You check the thrust wear surface on the crankshaft.
Right, and that's the middle one, right?
On RBs, it's in the middle. Other motors, it could be the rear. Like on Barras, it's number 5.
Oh, what?
Yeah, so that's these faces in here. You got one on each side. So normally, it's the rear thrust that's the one that cops all the abuse. Because like automatic gearboxes will throw the crankshaft forward into it.
Oh, wow.
And like you think about when you press on that clutch, that's going to put forward pressure onto the crankshaft. So That's usually the side that'll have wear on it if it has any. And yes, if you have a thrust bearing failure, it's normally the rear. It'd be very uncommon for the front to fail unless you had a end float issue with your crankshaft.
Right.
So number 4, we're at 3 and 7. And it's round again. So that's really good that they're all round so far. Alright, we're the same size on number 5, and it is also round. When you got a trend of it all being the same, that's good.
Yeah.
It was made well and it's lasted well. And we're the same size again on number 6. And the 2/10 out around 63 and 9, sorry. And we're right in the middle again on the end. So we're at 64 and we're round.
So was there 7 of those?
Yes, 7 main journals. I've just spotted something that might be an issue.
Yeah.
You're going to need a snout repair on this crankshaft. Somebody has ruined your Woodruff keyhole where the timing gear goes on.
Yep.
It's very unideal. It's worth repairing because everything else is fine. So you can see here they've damaged the snout of the crank. The Woodruff key that locates the timing gear has been completely torn out. This hole has been quite badly deformed. It's meant to be like this one in front here.
Oh, right.
But yes, obviously if you were to try and run that, your timing gear wouldn't sit in the right place and
I getcha.
it's going to move around and it's not going to run correctly and cause some major problems with valve timing. And you can also feel that it's quite worn on the snout on the underside from that. But it is repairable. Considering the rest of the crank is in good condition, it's worth looking into, especially if you don't want to spend a couple $1,000s on a stroker crankshaft. So the other thing on these RBs is if you want to run a good oil pump, you need a longer flat here to run the better oil pumps. So instead of just having this little flat here, which you can see has got a bit of wear on it, they tend to round off after a while. The RB26s and whatnot have a longer flat that comes all the way up to here. Or if you're grinding it off anyway, you can get a different drive style for your oil pump so it lasts a lot longer.
Yeah, so that would be like the sine drive you were telling me about?
Yeah, so you got the sine drive or a spline drive.
Yeah.
Or just like the RB26 style of the long flat.
So there you go, that's everything measured. So I know that there's a couple of things that need to be done on top of what we've talked about in terms of internals with the pistons and bores and that sort of stuff. So something about a tensioner?
Yeah,
so timing belt? So
when you put a 25 cylinder head on, because obviously you're converting the 30 from a single cam to twin cam, you need an extra belt tensioner because of the length of the timing belt you need to run.
All right, let's have a look at that.
So yeah, luckily for you, you have a later series RB30 block. Because the early ones don't have this boss around this threaded hole here. It's just comes along, has a small gusset around it, and it's normally recessed a little bit.
Yeah, right.
This is where you stick one of your tensioners. Obviously, if you don't have this there, the tensioner doesn't like to sit on it properly and they tend to bend over. People tend to weld washers or machine it, put in an insert so that it's got nice support for the back of the tensioner. And then you need to also drill an extra hole up here to run the second tensioner on it so you can get correct tension on your timing belt.
So I can't reuse either the 30 or 25 standard timing belt for this setup?
No, it needs to be longer. It's got to go around 2 cam gears and you've got more height to the block.
That's right. I think these days there are just off-the-shelf kits you can buy specifically for a 25-30. So is that basically it then? Like drill that hole up there?
Yes.
And just clean it out and slap it back together basically?
Yeah. If you're trying to simplify the process, yes. So we'll turn the block over and have a look at the bottom. So we've got the nice oily end now. You can see that this motor has had quite the lifestyle of missed services. It's all very black and built up of carbon on the inside of the crankcase from just its long life, I would assume.
Yeah.
It's nothing major, it'll all come off in the wash. But luckily for Ravi, it looks like it's all standard bearings. All genuine Nissan, and they're all standard. But yes, if you were to go and do a stroker in this, you need to do minimal clearancing. It's just a little bit on the bottom of the cylinders, just right in the middle here. That's normally the beam of the rod gets a little bit close, and the rod bolt gets a little bit close to this main oil gallery on the side here. So you need to just notch those on those 3 cylinders. We're only taking away what absolutely has to be taken away. It's not going to affect the strength of the crank casing or anything. If you had a catastrophic rod failure on 1, 2 or 3, you're probably going to take out your main oil gallery from the oil pump. But that's not going to happen. Not to you, Ravi. Normally that happens in over 1,000 horsepower builds.
Who says I'm not going for over 1,000 horsepower? Talk to me about the bearings. So main bearings?
So they're all standard. You can tell by the marks in them that it's seen quite a few kilometers. A bit of heavy abuse, but nothing is visually picked up badly. Number 1 here is nearly through to the copper, but doesn't have any signs of picking up on the crankshaft. All the parting faces for the main girdle look good. They haven't been moving around unnecessarily, which would be a bad sign that it's been extremely abused. But
So, sorry, what's a parting face?
So the parting face is this machine surface here that takes the other half of the crankcase, pretty much.
Yeah, right, okay. So that's what the girdle bolts onto?
Yeah, so your girdle will bolt straight onto here. Yeah, in RBs you got a whole cradle, which is all of your main caps connected together.
Yep.
It is stronger for the fact that your cap can't move like this under load. It does help when you're going for bigger numbers. RBs have a tendency to have crank flex because of how thin they are, but it's not normally a major issue when you're at the lower end of the power range.
Right, okay. So it shouldn't be an issue for me.
No. Especially when you put a new upgraded oil pump on it compared to the stock one. But yes, it's when you push them very hard and lots of boost, the crank tends to flex a little bit, and you can do in the main bearings.
All right, so we've just had a chat about what all those numbers mean. I think overall it's relatively good. Hopefully not too much work needed.
It all measures up pretty good. You're just going to need to go oversized pistons, 20 thou. All the rods look fine. Crankshaft measures great considering it's got some light scoring on the big ends. It's just the snout issue with that broken keyway there. The snout already needs to be ground for the new crank collar anyway, which is a standard kind of thing to do to an RB crank when you're doing a build.
Oh, right, yeah, so it would all kind of be done at the same time anyway.
Yeah, so they'll already be setting the machine up to grind that, so they'll just weld the snout first and then grind them at the same time.
Oh, well, that doesn't sound too bad.
Yeah.
Okay, cool. So as far as bearings go, there was a couple of them measured up, like with a bit of wear.
Yeah, a little bit of wear, but it's all within tolerance, so you get away with going standard big ends and main bearings. Yeah, so it's some of the little things that a lot of people don't realise. And
like
bearing clearances is one of the most critical things in the inside of the bottom end.
Yeah, definitely. And I mean, seeing how much like work and like precise measurement, like, you know, you had to do today to come to those numbers, has, you know, made me realise just how important that sort of thing is. I've never thought about bearings. I've literally never put any thought into bearings ever. I know how to take a turbo off and put a bigger turbo on. Woo! But this is the kind of stuff that keeps your engine not only running, but running well for a long time, I guess, you know, picking the right things and replacing them with the correct choice. So that's cool. Thank you so much for coming around today, man.
Try that again.
Anyway, thank you so much for coming around today. No, it's got to be that. It's the what?
Just having a stroke. It's all right.
Actually, no. Technically, he's going for a correct handshake, so. Now I don't. Anyway, thanks so much for coming around today, man. Really appreciate it.
No worries, man.
And yeah, if you guys want to see more of this build, make sure you like, subscribe, keep in touch with us on Facebook, Instagram. I'll be putting up updates on this build and the rest of the Stagey build as we go along. And yeah, see you guys soon.